Hello and welcome back. Today we're talking about variables in quantitative research, and we're going to be focusing on a selection from chapter 4 in our textbook. Okay, slide 2. So what is a variable? It's a characteristic or an attribute, and it has to have two qualities. First of all, it has to be able to be measured. It can be assessed on an instrument or observed and recorded on an instrument. Just have to be able to measure it. And also, it has to vary. It's not a variable if it doesn't vary. It has to be able to assume different values or scores for different individuals. Now, specifying variables. Let's say we had variables like leadership style or organizational control or whether or not a student was on the autism spectrum. These are things that are pretty clear. We could identify, we could give some kind of assessment for leadership style. Same thing for organizational control. We could interview and get details about that. And the autism spectrum, there are checklists, that kind of thing. So, possible to measure, varies among individuals. Now, there are other things that are measurable but are more difficult to measure. Things like the degree that someone is socialized into a particular culture. Imagination, intuition, the experience of discrimination. These are definitely measurable, but more difficult to measure. And then there are certain variables that are almost impossible to measure. And so we usually, there are certain constructs or ideas that are almost impossible to measure. So we usually use some kind of indication to capture some part of the experience. So for example, subconscious thoughts. We can't like peer into someone's brain and see what they are thinking, right? Unless you believe in psychics. Um, it, we don't have a tool for measuring subconscious thoughts. But we can ask someone, well, what were you thinking, right? So we can rely on self-report in that case. World poverty. Some things are difficult to measure because of the scale. Okay, and also we'd have to have a very clear definition of poverty. Now, of course, there are measures. If you go to the OECD website, you do see information about world poverty, but it's a difficult thing to count. How many impoverished people are there in the world? It's difficult to count. Stereotypes. This might be something that is inside someone's head. What stereotypes am I holding on to? Hard to see, hard to measure. Not impossible, but almost impossible to measure with any kind of certainty. Now let's talk about variables and constructs. I mentioned that word just a moment ago. A construct is an attribute or characteristic that's expressed in an abstract or general way. Usually the construct is what we really want to know about. And then the variable is the attribute or characteristic stated in a specific or applied way. The variable is what we can actually measure. So a construct might be student achievement, right? But that's a very global term, right? And we might measure that. Our indicator of student achievement might be grade point average. So our variable to represent student achievement would be grade point average. Now, there are different types of variables, and the type of variable or the data type has consequences for what type of analyses we can do. The first type is not listed on this page at all. Some variables, and you can almost think of a variable as a bucket, right? It's the label that we are giving to a piece of data that we're going to get on an individual, right? Some variables yield text responses from people. um, and so, but we're talking about quantitative variables. So this is things that might yield some kind of a number, a quantity, some kind of a choice, something that is constrained. First, there are two main types. There are categorical measures. Categorical data type is one of the data types, and then there are continuous measures. Continuous is the other data type. A categorical measure is a value when the value of a variable is assigned by the researcher into a small number of categories. For example, gender. We might measure gender as male, female, or other. That's a small number of categories, right? Now, um, categorical measures can be further described by whether they're nominal, ordinal, or binomial. Nominal means they're named without any kind of order. So, for example, if I were to ask you your favorite ice cream, you might say Rocky Road or chocolate chip cookie dough. These are different names of flavors of ice cream, but there's no particular order in terms of ranking them, right? Generally speaking. Ordinal, however, they can be ranked. Ordinal categorical measures can be ranked. So the most common of this is what's called a Likert scale. That's whenever you fill out something like your course evaluation, where it might say something like strongly agree, agree, neither agree nor disagree, somewhat disagree, strongly disagree, right? And so we have a rank order from strongly agree to strongly disagree. There's an order there, but there's still categories of responses. And then finally, binomial variables are those that are either yes or no. If someone were to ask me, hey, Dr. Campoli, are you male? No. I identify as female. Okay. So that yes or no. And the binomial variables are sometimes called dummy variables. A continuous measure is when the value of the variable can fall along a continuum of scores from low to high, like age, okay, height, weight. Yes, all of those things that can go from low to high. And continuous measures can be further described by whether they're interval or ratio. Interval just means that the space between each level is consistent. So age, for example, there are 365 days between being, say, 45 and 46, right? And the same number of days between being 46 and 47, and so on. Ratio means there's a true zero. And so age is a ratio variable. So for example, you can be 0 years old, and my son was 0 years old until very recently. And also, when my daughter is 6 and my son is 3, my son will have been, out in the world on the planet half as many days as my daughter. The ratio, you can talk about fractions when a measure is a continuous ratio variable. The main things to know are categorical and continuous. Okay. Rule of thumb, if an ordinal categorical variable has 7 or more levels, you can treat it as continuous. So if you had between strongly agree and strongly disagree, you had 5 things that people could choose, it could be treated statistically as continuous. And we'll talk about things like that more later on. Okay, now let's talk about families of variables. The dependent variable is the thing that depends on what you did. It's an attribute or characteristics that's influenced by the independent variable, and the independent variable is like what you did. All of this language comes from experiments. Okay, so um, the let's say we were trying to choose the best math program for students in an elementary school, and we had half the kids in the school got program A and the other half got program B, right? The dependent variable would be their math achievement at the end of our little experiment, okay, or big experiment, depending on how big the school is. So it's the outcome, the effect, the criterion, the consequence. It's we should be able to answer what outcomes in my study are I trying to explain. Now, on to slide 7. The independent variable is the attribute or characteristic that influences or affects the outcome, or the dependent variable. So the predictor. We say we have a predictor variable which influences an outcome variable. It might be a treatment. In the case of the math programs, the treatment would be which program students received. It's a measured variable. One type of independent variable is called control variable, and other types are mediating or moderating variables. And we're talking about what variables or factors influence the outcomes. Now, there are some kind of like variables that we include in our study, even though they're not directly what we're trying to either affect or what we're using to affect something. So they're not the math program, they're not the student test scores in math. They're other things. Control variables are what else do I need to measure or control so that I can make sure that I'm actually figuring out whether or not my independent variables are influencing my outcomes, my dependent variables, and it's not other factors. So the most common control variable used in education research is student socioeconomic status, okay? Because we know that the income level of students' families influences their achievement, right? And so we may want to control for that when we are trying to see whether one math program is better than the other. Confounding variables are other variables that may influence the outcome but cannot or will not be measured. Let's say we're doing the study on math achievement. And maybe creativity. We believe that creativity, can affect math achievement, but we're not actually going to be testing the kids' creativity. So they could be an explanation that some of our more creative kids are better at math, and but if we didn't measure it for our study, it's a confounding variable. Sometimes these effects cannot easily be separated from other variables, and they may influence the relationship between the independent and the dependent variable. Now, in your text, it says it kind of equates confounding and spurious variables, but spurious variables are usually not the same as confounding variables. Spurious variables refers to variables that change along with an outcome, but don't actually explain an outcome. So, for example, shoe size is linked with intelligence. Yes, it is. People with bigger feet tend to be smarter than people with very small feet. How do I know? Because if you were to give an intelligence test to everybody in my family, the 2 people with the biggest shoe size would do much better than the 2 people with the smaller shoe size. Yes, grown-ups do better on intelligence tests than kids. Grown-ups know more than kids, right? Grown-ups have bigger feet than kids. Does big feet cause intelligence? No. So that would be an example of a spurious variable. Now, the independent variable, you can think of it in different forms. There's a treatment variable. For example, what math program did the kids get? There's the control variables. That's those things that are measured and important to neutralize, like SES is often a control variable. Now, there are moderating and mediating variables, and um, we're not going to worry too much about those. Basically, a mediating variable stands between your predictor and your outcome. A moderating variable changes the effect of whatever your intervention is. So, the for moderating, a good example is summer slide, right? So, over the course of the summer, kids forget what they learned during the school year. Um, and so, if you have a summer program, then often, usually, kids will forget less if they're in school in the summer. However, this is moderated by SES. So, if you take a very wealthy child and put them in summer school, um, um, their achievement might not be as good as if you had not put them in summer school. If you take a low income child and put them in summer school, you expect their achievement to be better than if you had not. Why? Because the wealthy child is going off to, I don't know, robot building camp or doing international travel or doing all these other kinds of things that might enrich their education. Whereas the low income child may not have those opportunities, most likely does not have those opportunities. And so they really benefit from um, summer school, right? So SES moderates the effect of a treatment like summer school. Okay, so just slide 10 is just a visual for you. Um, so we get independent variables, mediating variables, and dependent variables. Control variables affect dependent variables. Moderating variables affect the relationship between the independent variables and the dependent variables. Confounding variables are somewhere out there, but we don't measure them. Theory, ideally, will bridge independent variables and dependent variables. Okay, so we use theory um, to predict or understand the relationship between what we did and what the outcome was. Now, there are different levels of theory in terms of how abstract they are and how much they've been tested in a body of literature, tested by other researchers. So, a formal theory is expressed by connected hypotheses and variables identified by authors. And in education, there are a number of formal theories. So, for example, multiple intelligence theory, right, is a common one, a well known theory. Um, Next down, you might have a conceptual framework. Now, a conceptual framework it's like a theory, right? It might be expressed as a visual model by authors to show the relationship. And I like putting conceptual frameworks in my papers because it shows the relationships among the variables in a conceptual way, in a visual way. I'm not saying that they're necessarily formal theories, though, because in order to be a formal theory, it has to be tested in multiple ways and usually by multiple researchers. A theoretical rationale, you might say theoretically, based on the work of such and such, we believe that da da da. Okay, so we're providing a rationale that we, in theory, would explain our relationship between our predictors and our outcomes. Okay, but it hasn't been tested enough to be considered a formal theory. And then finally, you got those hunches. Based on my experience as an elementary educator, there are certain things I can tell you. Okay. Um, um, we don't put the word hunch in our in our formal research reports. But whenever we're not citing a specific theory, whenever we're not using a conceptual framework that where we're drawing from various sources in the literature or theoretical rationale where we're drawing from at least some concept that's somewhere out there, then it's a hunch. Okay, let's talk about theory of action. We've talked about action research, and we're talking about making change in a school context. And so Project Zero at Harvard, they have worked with a lot of educators and other leaders on theories of action, right? And we used this in the Harvard Institute on School Leadership as well as our school leaders from around the country were developing their plans of action. They had to identify what they had to specify what was their theory. And the reason is because a lot of the things in education, a lot of our we know implicitly. We're in the middle of it. We know implicitly. We believe fundamentally some things that we don't often articulate. And it's important to articulate these things in order for us to be able to test them. Okay, we want to make some of those things that are invisible visible. So, for example, a kind of a long theory of action that you can find on the Project Zero website. They have a resource where you can try creating a theory of action. The long, kind of a longish example they gave was this. If teachers start to use sentence frames for their classrooms, then their learners will gain practice in expressing their thoughts. And if that happens, then learners will become more comfortable expressing their thoughts and they will begin to routinize self expression during class time. And if that happens, then learners will begin expressing themselves independently even when not prompted to do so. And if that happens, then learners will begin expressing themselves both inside and outside of the classroom. And if that happens, that will lead to our group's long-term desired outcome of empowering learners to express themselves. Okay? When you look at a school's website or even when you first walk in, often there are these mottos, these vision statements, these missions, okay? And they often use very lofty abstract language. Sometimes it's helpful to try and trace how do our school practices relate to that final outcome that might show up in a mission or a vision statement. We want to show the stepwise cause and effect, this chain reaction or order of implementation steps that we expect to occur as we're trying to innovate in schools. So let's check your understanding specifically for data types or variable types. So if I asked you what is your name, would that be continuous or categorical? That's actually a trick question. It would be text, okay? And really neither continuous nor categorical, because there are infinite different names that a person could be named, and they're not in any particular natural order. So it would be text. Okay, so going on to gender. If I were to ask, what is your gender? And wonder where I got this list of questions. Okay, what is your gender? Is that continuous? Is gender continuous or categorical? That's another trick one because gender can be thought of on a continuum, right? And and if a person can fall anywhere on that continuum, that then we would consider gender continuous, right? But normally when we are doing a survey and we're asking people that question, we expect them to fall into one of three boxes, either male, female, or other, right? So then it becomes categorical with three potential categories. Okay, what degree are you seeking? Is that continuous or categorical? That is categorical. Okay. And in fact, it's categorical and ordinal. There's an order to it. Um, a master's degree is higher than a bachelor's degree. An EDS is higher than a master's degree. And a doctorate is higher than a specialist degree. Okay, so there's an order there. So it's categorical, ordinal, or ordinal categorical. How about where do you work currently? That one might be text, right? Because we could have some infinite number of different names of schools, for example. But if, let's say I was asking about what county do you work in, I would consider that categorical. For example, the students in our class work in either Columbia or Jefferson or Richmond or McDuffie, right? So then there are four categories. And when we're naming counties, that would be nominal. There's no natural order to the list of counties, the way they are with degrees. So categorical and nominal. How long have you been in your current role in years? That one, like age, is continuous. All right, so that concludes our introduction to variables. Okay, see you next time.